Families, it's time to review some fractions. At the top, we have two number sentences that compare fractions. They're asking what would be filled in over here in the denominator to make this number sentence true. So if I read this, it says 2 something, I don't know the denominator, is less than 2/3. I know that this one has to be less than this one because my symbol is pointing at the smaller fraction. Okay, well I notice that they have the same numerator. When fractions have the same numerator, you look at the denominators. So the denominator of 3 tells me that a whole is broken into 3 pieces. Because there's only 3 pieces, they're pretty big. In order for this number sentence to be true, I would need to put a denominator here that is bigger than 3. If I put the denominator 5, that makes the number sentence true, because a whole that is split into 3 pieces has larger pieces than if the whole was split into 5 equal pieces. So I can see that 2 of these thirds are bigger than 2 of these fifths. That makes the number sentence true. Over here, I need to fill in a numerator that makes this number sentence true. 3/6 is less than how many 6? This number sentence is a little bit different because the denominators are the same. When the denominators are the same, you look to the numerator. That's easy. You just look at numerators in terms of how many parts are shaded in out of 6 total pieces. So if I have something that's split into 6 equal pieces and I have 3 of them shaded in, well, I can just shade in 1 more, and that makes the fraction larger. So I could say 3/6 is less than 4/6 or 5/6 or even 6/6. Let's look down here. This question is asking me to plot 1 whole on this number line. Well, in looking at the fraction 5/3, I notice right away that that's an improper fraction. I can tell because the numerator is larger than the denominator. That tells me that this is a whole that's broken into only 3 pieces, but there are 5 of them. So if I look at that in terms of a picture, okay, there's 1/3, 2/3, 3/3. I need to make another whole and split it into 3 pieces. So I have 1/3, 2/3, 3/3, 4/3, 5/3. So I know right away that 5/3 is bigger than 1 whole. So I know from here at 0/3 to 5/3, there need to be 5 pieces. 1, 2, 3, 4, 5. Okay, so now I can start labeling them, keeping in mind though that they're still thirds. Kids are going to make that mistake. 1 whole is right at 3/3. That's where I have 1 whole thing, or like this, 1 whole picture. So even though we broke it up into 5 parts to get those 5/3, 1 whole is still here, where there are 3 of the thirds needed to make 1 whole. Here we have equivalent fractions. So this is telling me to shade 3/4. But I notice in this picture that there are actually 8 equal pieces. Excuse me. So I can do this a couple of different ways. First, I can think about, well, I have 8 equal pieces. So what is my equivalent fraction in 8 to 3/4? Well, I know from my equivalent fractions flashcards that I study every single night that 3/4 is equivalent to 6/8. So I can do it that way and shade in my 6/8. The other way I can do this is to look at this instead of as 8ths in terms of fourths. So if I split this here, here, and here, I can see this whole thing as a fourth, that whole thing as a fourth, that whole thing as a fourth, and that whole thing as a fourth. And then I can just shade in 3 of these fourths. Something else that our kids have done is they'll look at it in terms of like this is a group of fourths and this is a group of fourths. So our kids might say, oh, okay, well 1, 2, 3 of the fourths, and then 1, 2, 3 of the fourths. So they might kind of split it up into 2 different groups of fourths, and that's okay. Because if we split each fourth in half, that's how we get our eighths. Thank you.